Right, so let's get started on time today. Happy Monday, everybody. My name's Florian from the ads targeting team, and I'm stepping in for Daniel today, who's not in the office. And yeah, I actually have the pleasure to introduce somebody outside of Yelp today, namely Kevin, who is from the UC San Diego. And he is one of the winners of last year's Yelp Data Science Challenge. And I assume he's going to talk about that and even more curious data projects. All right, stage is yours.
Hi, folks. My name is Kevin. You can call me the Data Evangelist as part of the Data Science Student Society, UCSD. And this presentation, I'm going to demonstrate to you the fun projects we're doing with your authentic and rich data set, and in addition to other projects as well. Okay, let's get started. So UCSD, how many of you have actually visited there? Are you UCSD students? Oh, alumnus. I'm in good company. Well, for the majority of you who haven't visited there yet, it's a great and beautiful school. We're located right next to the Pacific Ocean. So like here are some scenic sites you have to check out if you're ever in San Diego. Middle picture is our infamous Geisel Library. It's actually been featured in a movie. How many of you have watched Inception? Does the Snow Fortress bear any resemblance to this monstrosity of architecture? Some people have called it a spaceship or a prison. I think the latter is more fitting. And the bottom right is Salk Institute, named after Jonas Salk, the co-inventor of polio. It's a really nice place to visit. And these pictures, by the way, were gathered from Yelp users, and just wanted to show you like the power of crowdsourcing like content. Actually, the one on the left bottom is taken by myself because I didn't find like that building to be satisfactory, so I added a picture just to show I care about my community. So that's a little bit about UCSD. So why is UCSD so special in terms of data science? It's due to like our rich history of the inventor of data scientists, the man who coined the term, DJ Patel. He's the chief data scientist of the White House, and he did his undergraduate degree in mathematics at UCSD. So the man in the middle is our faculty advisor. He's a zombie neuroscientist, and he works for the Zombie Research Society. He used to be a data scientist for Uber. Now he's our faculty advisor for our data science club. Finally, the alumna on our left is Diane Hu. She's a data scientist at Etsy, and we hope to have her back for a guest lecture, hopefully next year. And if you want more information, please check out the Data Science Handbook. It's a compilation of interviews from Quora, and you can get it for free. And it has really good insights on like interviews from real data scientists. So finally, we get to the main part, which is presenting the projects we've been doing like this past year since we just started up. In fact, like in the weekend conference, a lot of people were surprised and pleased to hear that UCSD has actually a data science student organization. I think that's pretty unique among the colleges. And one of our flagship projects from last year was the Yelp Dataset Challenge, which we'll start to analyze right now. So this was 2014, and essentially we took a subset of the data of the Yelp dataset, academic dataset, and we performed the basic exploratory data analysis before doing a machine learning task. What we found was that it seems like there's a heavy skew towards like the 4 and 5 star ratings, almost 80% of our sample, whereas the 1, 2, and 3 star ratings like around 50 to 20%. And like seems like Yelp users are pretty optimistic. And like some of the word clouds that we ran on the different star categories, like 1 star, 2 star, 3 star, 4 star, 5 star, show that the common keywords for doing a really successful business are having Mexican, Chinese, and barbecue food in Las Vegas, apparently. And be sure to have Wi-Fi, good parking, and friendly staff. And for dessert, be sure to have ice cream. We were analyzing different features we could possibly use in the machine learning classification algorithm, and we were exploring different features, and one of them was token length. Fortunately, though, for each of the star categories, the token lengths were roughly clustered around the same values, like 50 to 200. So we decided to explore other features too. Here's like these features that we were exploring were highly correlated and couldn't really make sense, but we included it here just in case we needed to look back and hopefully improve in the future. So these are like the funny, the user, and essentially all those social social buttons like in the app, and the table of correlations. And here we performed multi-dimensional scaling based on the text for each star category. And we found like there wasn't really much of a pattern except for like the similarity based on text. Otherwise, the scatter between the star categories are roughly really similar, with 4 stars being the most varied, like the purple. It's spread out across like the entire plane. And we also examined the similarity of the words in each of the reviews. And for example, like the words that appear closer to each other, like on this plot of the word similarity, usually are bigrams, we've noticed, like airport and terminal. And I think there was a pattern here, pancake or server, IHOP, interesting. And we also wanted to play with the check-in data that the academic data set provides, and like we plotted like the most popular like businesses in terms of being checked in, and again the analysis confirmed like it was based on how similar the texts are. So I'm not sure like how we intended to incorporate it, but it was like one of the last visualizations we did. And finally, we also like utilized the check-in to visualize over time. And like what we found was like 2011 was when Yelp really started to get kicked off. Like the reviews, like or near towards the end of December, or December, like the winter of 2010, like check-in started to appear more frequently. And other than that, like in the previous 3 years, it was actually pretty sparse. But from 2010 onwards, yeah, there's a much more amount of check-ins. Finally, like we decided to give a classification a go. So the question is, given the text of each user reviews, can we classify accurately as 1, 2, 3, 4, or 5 stars? And we ran several different algorithms, and including one that we implemented ourselves, which is a naive Bayes, because we read in our class that it was a very simple algorithm to implement. And we even tried like different customizations of variations of it, like multinomial or like Bernoulli. And we used different features like unigrams, trigrams, and bigrams. And we organized all the accuracy results in a nifty interactive table that could be sorted, compare amongst each other. And for the metrics that we use to score the accuracy, we utilize precision and recall. They're usually used in binary classification, but in our case, we have multi-classification. Since we don't have only 2 categories, we have 5, 1 for each star rating. So we take the basic idea of precision and recall, and we use a single statistic summary, just find the average, the mean for each precision and recall of the star categories. And so we define the residual sum squared to be like the deviation from the average precision and recall. And so this is something called a confusion matrix. It's a square matrix. Since we have 5 different star categories, we have the true label, like what they actually represent, and our predicted labels. So these are a quick way to visualize how accurate our algorithms are performing. And this is essentially like the visual result from the table. And it just gives you another way to easily tell how accurate each algorithm performs on different star classes. As we could see before, since 1, 2, and 3 star reviews were very sparse compared with the 4 and 5 star reviews, which appeared almost 80% in our sample. The algorithms that we ran focused on optimizing the accuracy of the 4 and 5 star reviews to the detriment of the 1, 2, and 3 star reviews, which are very, very inaccurate. So we were kind of worried how we can improve the accuracy given this worrying results. And looked through several papers, and we applied it to our naive Bayes classifier that we implemented. And so the tech was supposed to be interactive, but this was supposed to be the math part. Is everyone okay with not reviewing the math, or are you math fans here? I'm a math fan, so this makes me sad, but you can view it at a later time. I'll share the slides with you. And so we continue looking over several research papers and attempting several suggestions. But in the end, we decided to give one last strategy a chance, which was a strategy called oversampling. Essentially, since the 1, 2, and 3 star text category reviews don't appear as frequently, a strategy you can use is duplicating and increasing the size of the sample with the minority classes 1, 2, and 3. So we introduced more copies of the 1, 2, and 3 star reviews and reran our algorithms. And we get slightly better results from the previous, but not that much better. Finally, our best algorithm variation was diagrams, because we found the multi-dimensional scaling plot. Remember the one with the airport, the terminal, and how similar the diagrams appear to each other. So we found that the bigram multinomial variation of naive Bayes that we implemented actually has, or my cursor is hovering, has the nicest visualization result. You see it's really, really balanced amongst the classes. It's not as accurate predicting 4 and 5 stars, but at least it's more accurate predicting the 1, 2, and 3 stars compared to all the other classifiers. Just a great relief. So that's why we presented it as our best model and one that's most fair. Some additional results, and finally, we wanted to end off with this, because this was actually created last year during the winter holidays, and wanted to celebrate the holiday season. So we gathered a bunch of food text menus, and we filtered the different text reviews of users to see what they're eating. And for Thanksgiving week, seems ice cream and pad thai and prime rib are our favorites. Carne asada is something you should definitely get when you're in San Diego. They're big on burritos and carne asada. And for what Yelpers are doing during Christmas, they're mainly shopping instead of eating. So we don't see too much food. A lot of people are at Disneyland, obviously. Costco. Yeah, it's very nice, very interesting way to end our submission. And yeah, and we actually posted, that's right, the internet's not good, but posted the results on our custom website. I could share with you later as well. So that was our flagship project for 2014, and we were really happy to get the chance to play with your data and to run our algorithms on it. And a second project that my partner Sang was supposed to be here to share with me, but I'll share on his behalf. Sang, his story is he was a pre-med student, and although he was accepted to medical school, he decided he wanted to be a data scientist. So it's important to follow your passions, really. And he's thriving right now, and this visualization really shocked our school. Everyone was so pleased to see how the different majors stack up. So mainly the people who put more hours studying at our school, UCSD, are the engineering and medical school students. So I guess it pays off, right? Being a data scientist, heavily compensated. And the other project he's doing is something called Explain to Me. So this is a text mining application that goes through different research publications like medical journals and textbooks. And if you enter a number and integer, it can summarize that fat volume of text into a condensed a summary, a 10-sentence summary. And he does a lot of fun stuff with natural language processing. He's really big on that. So that's one of his projects that he shared with us. And the last one I want to share is we analyzed Macy's wedding data this summer. And this is a really fun one that I think you guys will like. So wedding data analysis, yes. And essentially we're given a data set from our friend Brian. He's also part of our student organization, and he works at Macy's.com. So actually he gave us some access to the data set. His main focus is to optimize the search engine so that Macy's appears #1 every time you search on Google. And but we're trying to see what kind of insights we can provide to him, how they can craft their search engine results to be the most popular. So, the way the data was gathered was through a script he wrote, and we got a bunch of history results from Google, and Sang, he ran a LDA application, or that's later on, but some of the summary statistics that he shared with us, popular keywords and titles of the search results, and the average scoring of how high it ranks. And we found by plotting the keywords in a visualization d3.javascript, we found this usually tells a story that essentially there are two types of users who search for weddings. One is the wedding guests. They search for gift ideas, and the wedding hosts search for invitations and checklists and all the things you need to organize for a wedding. Yeah, and this is a quote from Wikipedia. If any of you are getting married recently, or planning your most memorable wedding, what a bridal registry is a service provided by a website to assist engaged couples to communicate the gift preference. So this is actually a really big business, obviously. When we ran word clouds on this data set, it was as interesting as the one on Yelp because there wasn't much variation. All you see is the keywords that show up, fortunately. But we did find that the higher ranked results usually have a smaller vocabulary size. And so that just teaches us we need to focus on more relevant words. But which ones exactly? In this plot, we found the top 20 keywords from each a result rank, ranked 1 to 10, the first 10 results on Google when you search Macy's wedding. And Seems like plurals are really bad, so use singular like forms of nouns and certain like keywords like yeah, wedding and gift obviously, but some other unusual keywords are real, popular, not in gift items for the bride. Okay, this is the fun part, LDA. So we've been learning this a lot in like our data mining classes at UCSD. And like this has been really popular topic like in university and research. LDA is like a text classification algorithm that analyzes all the text data that you have, assigns like topics. Like it recommends like topics that your text is talking about. So we chose like 7 items. Well, I chose 7 items and Sang used 10 items. And he found the topics like the type of the material of the gifts, like their art or made of glass or dishes, glass gifts or like handcrafted. And when I ran it using 7 topics, I found like different websites and like the impression that they show to the users. Like for example, websites like Personalization Mall usually associated like with magical feeling for the users, and BuzzFeed is it's like based on news, so it's really time heavy, time focused. And like for Pinterest, it's usually like very visual and like it's used for users who want to discover discover the wedding. Okay, so this is a LDA viz. Like they have a R version and the Python version too. So actually, it's just a visualization of what we listed above here in this table. So using this, you can find suggestions for like the topics that your texts are talking about. And we use the multidimensional scaling again to show like where Macy's compares with their competitors. And they usually fall near like the heavy retailers like Amazon and Kohl's. But Nordstrom and usually it falls like near like more personalized and specialized retailers. And this is another exploratory technique called hierarchical clustering. Also measures similarity in a different way. Like it actually ranks it in order, whereas compared to multidimensional scaling, it takes like all the data points into account. Whereas this hierarchical clustering, however, it compares like each website in order. And but we gave Macy's.com like their search strategy board some advice, like essentially what we've mentioned before, keywords to be used, and how it compares with its competitor. It's really popular, like Etsy right now. They're competing with Amazon. Like they're really personalized online shopping, and so we were wondering why Etsy was so successful. And we were fortunate enough to ask Diane because she worked at Etsy.com, and her advice was quoted here, since our most traffic categories, or one of our most traffic categories is wedding, and they sell basically a huge breadth of products, and a lot of people discover Etsy for the first time. So essentially it's the volume of the products that they sell and the variety, and essentially anyone can be a vendor, and the first impression is important for the couples who want to purchase wedding gifts. And this is a pair plot, but essentially it correlates the number of words with the ranking of search engine results, and the number of words, usually 8 to 9 for titles, is a good estimate for successful ranking results. And essentially we really want to analyze more Macy's data, so we just asked them a question. Don't ever be afraid to ask questions. The only stupid question is the one that's not asked. That's what my professor taught me. He teaches neural networks, so he's a pretty smart guy. And this picture was, I think I got this from Yelp too. Like a user submitted this. This is La Jolla Beach. It's really beautiful. They host weddings there. Think about it when like you get married. Yeah. And those are like 3 of our interesting projects we wanted to share. And I hope like that was like unboring for you and you were really interested in some of the stuff we did. And just want to thank you for being so excellent and sharing your data with us. Oh, by the way, like I thought like Yelp really liked pets and stuff. So I included this picture. Like the story behind this was like I was debugging this really nasty code and was feeling a bit depressed, right? So I just found like a puppy that came up to me and he like essentially kissed me on the leg, and I was like, wow, how nice. Unconditional love, there's nothing better. This is a Siberian puppy. They're very cute. And I love to take questions if you have any from the audience. Yeah, my fellow alumnus. Yeah. Yeah. Right. That's a really good question. Why did we not decide to tokenize words like or stem the words like for example like ing words like running, like going into like run or go? Like as you actually described, we did feel like it actually did affect the accuracy. And I think that was one of our findings too. It's like actually made it less accurate in our sample. So I'm not going to generalize this, but when we were running it on our sample, like actually made it less accurate. But we tried both, just to be sure. Thank you. Hi. Yeah. So let me repeat the question. Like in our plot for multidimensional scaling for business similarities, like was it due to like a similar like businesses, or like are they similar in popularity or the text? Am I stating your question correctly? Thank you for asking. It's actually more closely the former. So the similar businesses actually have the similar products. And one of the examples that we actually saw, we went through like the different like data points. We saw that breweries like were really similar. Like especially since we live in San Diego, the brewery culture like they have a wide selection of beer, and like we found like basically like similar businesses sell similar products more than like based on their popularity. Like in the multidimensional scaling plot with the scatter plot with the different colors, like the green and purple, we found like although like they were like based on like I'll go back. I was gonna show you like, but I don't have internet, but eventually like what that scatter plot was supposed to show was that like they weren't similar based on popularity. They were similar based on products and like the text. Check out the San Diego breweries. They have a lot of good beers there. If you're a data scientist, if you're a real data scientist, you should love beer. Any more questions?
No more questions?
the Yelp data, like extensions of it? That's a really, really good question. Like you gave us like really good data, like user data, but we didn't actually use it in our submission, and we would like to have the chance to reuse it. Thank you for asking.
All right, so I will definitely send out some links for that for those projects, so you can go into more detail there. I think especially the visualizations are quite impressive.
Thanks.
Yeah, so if you know something technical that it's worth talking about, which I'm sure everybody of you knows, feel free to just reach out to myself or to Daniel, because we actually do have open spots for the next applied learning groups. And other than that, that's it for today. And let's thank Kevin again.